Good morning, everyone. I, Raj, along with my group mates, are going to present before you our project on studying machinability of aluminum alloys by measuring surface roughness. Here is a overview of our presentation, which consists of an introduction, literature review, and the references. Coming to the introduction of aluminum alloys. Use of aluminum alloys can be found in every field of our day-to-day life. This alloy is chosen because of its high specific strength property, which leads to high strength and extreme weight reduction in its applied machine components. Below given is a table of aluminum alloy designation system. For example, 2000 series of aluminum alloy has copper as its main foreign metal. Similarly, 3000 series of aluminum alloy has manganese as its main foreign metal, and therefore the list goes on. Coming to the next slide, here we can see the specific machine components where the aluminum alloy is used. For example, in the wheels of an aircraft, in the fuel tanks of a spaceship, or in the metal frame of luxury cars like Aston Martin. Coming to the next slide, here we give an introduction to what is actually alloying. Alloying is a process in which two or more metal elements are combined together in a precise combination to form a specific material or alloy. In this following table, you can see the advantages of using different metals in aluminum alloys. For example, copper in aluminum alloys increases the machinability of the alloy, or iron in aluminum alloys increases the stiffness of the alloy, and therefore the list goes on.
Respected teachers, I Kapil will be continuing with machinability. The reason why it is important to study about the machining of aluminum alloys is because aluminum alloys has numerous applications in various fields like automobile industry, space industry, etc. But it's very difficult to measure the machinability of aluminum alloys. Aluminum is soft by nature and can be difficult to work with. The machinability of a material is usually defined in terms of these factors: surface finish and surface integrity of the machine part. The surface finish is sometimes used to measure the machinability of a material. Soft, ductile materials tend to form a built-up edges. Aluminum alloys as well as materials with high shear zone don't tend to form built-up edges, so these materials would rank as more machinable. And tool life. Machinability can be based on the measure of how long a tool lasts. This can be useful when comparing materials that have similar properties and power consumptions, but one is more abrasive and thus decrease the tool life. Force and power requirements. The forces required for a tool to cut through a material are directly related to the power consumed. The higher the strength and hardness of the alloy, the higher is the cutting forces and the worse its machinability. Then surface roughness. Surfaces are distinct entities with properties that can be significantly different from those of the bulk. Upon close examination of the surface of a piece of metal, it is found that it generally consists of several layers. The layers are the metal substrate layer, then work hardened layer, then amorphous layer, then oxide layer, absorbed gas layer, and the contaminant layer. Now, surface roughness is generally characterized by two methods. One is the arithmetic mean value and another is the root mean square roughness. So this is a typical surface profile of a surface. Here A, B, C are the various heights of the surface from the datum line. In general, it is found that surface roughness increases with an increase in the feed rate and depth of cut and a decrease in cutting speed. Depending on the type of chips formed, continuous or discontinuous, the surface finish will increase directly with increasing friction between the tool surface and the chips formed. Generally, it is observed that the use of cutting fluids improves the surface finish, which is attributed to the reduction in the coefficient of friction as well as the size of the built-up edge.
Hello everyone, myself Balwant Singh and I will continue the slides. Take the reviews on aluminum alloys. Titles of papers and authors, publications and results. First is A. Almar Journal Age Hardening Time Effects. Publications Engineer ResearchGate 2000. Results are examine alloying process of aluminum alloy microalloy with cadmium. Next is Custer W. Material Science and Engineering 9th edition. Publications are John Wiley and Sons, 2010. Carried out extensive investigations on the mechanical properties of aluminum alloys. Next is TV Sunbaum Sentence 2XXX series of aluminum powder alloys. Publications Materials and Designing 2002. Investigated on the use of terrace additions of cadmium to enhance triplex alloy series of aluminum powder alloys. Next slide is Muhammad T. A study of effects of machining parameters. Publication the Jordan Journals of Mechanical Engineering 2007. Series of experiments to characterize the factor affecting machinability. Next is casing machinability parameters of aluminum-based alloys. Research India publication at 2017. Effects of surface roughness in machining of aluminum alloy at a cutting speed of 125 to 175 meters per minute. Next is Vimal Kumar, Machining of Aluminum Alloys, IRJET publications 1999, to analyze surface roughness with various combinations of design variable, cutting speed, feed rate, etc. Next is ASMO, Evolutions of Surface Roughness and Detect Formations. Publications are MDPI publications 2020. Development of bridges formed during the turning of aluminum parts made by DMLS process method. Next is Doctor Zafron and A. Mohammed experiments of surface roughness and tool wear on coolant conditions. Publications are Researchgate in 2017. Research indicates that up to a cutting speed of 270 mm per minute, a tool wear is generated and pose surface roughness. Last is an investigations of surface roughness. IJCSCN publication 2019. Series of experiments done on surface roughness. These all are references we have taken. Thank you.